guessing when we turn the lights off here, it turns the lights off in part of the CS area as well. Does it?
Yeah.
There's a few guys sitting in the dark over there.
Yeah.
So it looks more romantic for them. Yeah.
Nadia's going to get some light switches put in here, so it just turns off these lights and the one directly out the front there. Should be good for us.
We wait for anyone else? Is Muzza rejoining us for phase 2?
No, I haven't.
The one thing I'm taking away from this whole thing today is that the whole platform's called Cerberus. I thought that was just the acronym.
Yeah.
Yeah, that's really like that. What's really funny is some of the feeds a long time ago we actually had a project called Cerberus. The original names for the Cinema King stream game. There's actually a GitLab, there's a GitLab repo from like a year plus ago called Cerberus.
Is Blair coming back?
He just left.
He was here a second ago.
Like the building.
Yeah, like, I'm assuming so, because he only came in like 5 minutes ago, so.
No idea.
And he left his.
I just wanted to make sure
Okay.
you weren't sitting in the chair, I think.
I'll just start. Right. Oh, don't close the last tab. Otherwise, how will you know? No. Okay. I shouldn't have done that. Alright. So, console is the first thing that we'll be talking about. So this is our UAT console, and it basically does two things for this console. So the first thing it does is it manages to keep track of where all of our services are running. Right. If you ever have to go to the UAT console, the first thing you should know is that this button up the top here, that contains like a list of all of our environments, right? And so technically, when you're switching this, you're switching to a whole different set of console servers, but you're still going through, as the URL says, the core console server. So they're all federated to each other, which means that they can all see each other and see each other's values and everything, but they're actually like a whole separate set of servers running somewhere else, and they just know how to talk to each other.
And console itself is an open source tool.
Yep.
And you're just using it in its raw form, or do you like branch it to have this multi-domain, multi-product stuff, or are you just using console as it is, or
Yep. So this is just stock standard console. This is like this feature up here is what it calls its WAN nodes. So it's got two separate sets of nodes. It's got its LAN nodes, which are the local ones. So from the core console's perspective, its LAN nodes are all of these core ones here in the core services. So if you go to nodes, you'll see there's a whole bunch of nodes in here, and these are all the core console nodes. And then these ones in the other environment, they all connect to the core server as WAN nodes. So all of them all connect and talk to each other. It's just that you've got different groups of them, and they keep track of different services and different keys and values. I guess I should go here and just show you quickly. You can see basically all of these names that you're probably a little bit familiar with by now. These are the APIs. These are the feed processors. They start with the FP. These are SRVs. And we've got a couple of web ones down here. And conversely, for like the brand environments, we've got a whole different set of APIs, SRVs, webs, it's a lot of SRVs, and webs, and proxies. If you go in and have a look at one of these, you'll see that there's 3 running, and these are their IPs and ports. Hello. So these are like the IPs and ports that each of these are running on. So you can see that they're sort of all running on different servers on different ports. And if we start up more, they'll pick a random IP and port to use on a different server somewhere else. And also when we release a new version of this, it will start up 3 new ones and then gradually kill off the 3 old ones. It'll send termination signals to them. They'll finish serving out their current requests, and then they'll shut down and stop registering themselves and stop getting traffic. The other thing that we've got is the key values. I keep on trying to click on stuff over here, which isn't the actual window. Okay, so in the key value section, we've got a whole bunch of different top level folders. DMU is for the distributed mutexes. Lock is it's so that these processes can get a unique ID amongst themselves. Essentially, when these processes want to start up, they want to know, like, I'm on the first one, on the second one, on the third one. They want to get a unique integer. So this section here allows them to get an atomic lock on their process name and work out what ID they are. Service is basically the same as uservice, except I think it's the new name that they're trying to move things to. Essentially, you see there's like three things which you're using now, and it's essentially the same thing as you'll see in the uservice later. UI is for front end, like the front end website configuration. When it loads up, it loads up a configuration file to determine how the website functions and which features are turned on and off and what certain URLs it should be hitting up for various different things. uService contains configuration information for all of the services that require it. So if you come in here and have a look at any of these, you see a bunch of values are set. The service creates has a config structure inside of it, and it registers a watcher on this. So if I come in here and I change one of these values and save it, it will automatically update that structure in the running applications, and then they'll be able to, like, the next time they try and work out whether they're in fail mode or not, it'll look at the config and see, oh, it's changed from 1 to 0, so I'm not in fail mode anymore. So updating these is currently how we change runtime, like set runtime flags to change behavior while applications are running.
Is the intention that when you're fully across the Kubernetes that we ditch all the dynamic configuration stuff and use the rolling?
So the way that it's moving at the moment is that we'll be setting up config maps, which are mounted as a file inside the Kubernetes instance, and then the applications will load up that file and have a watch on that file to see when it gets updated, and then
we use config maps in our Kubernetes setup, but we haven't really needed the sort of watches because it's pretty cheap to recycle a pod, I guess.
Yeah, that's right. There's a lot of extra complexity there to just check that config, update it.
It depends. Yes, but sometimes there could be things that. Sometimes it seems easy just to restart a service if it starts up.
Yes, and kind of no, because of the amount of caching that we do. Sometimes restarting services can be an expensive way to do it, because it's got to go and actually hit up the database and fetch all of that new information that it needs all over again. So yeah, for things that are not likely to change, perhaps it's better just to load it once and start upload. And then the web directory works in concert with the UI directory, so that the web config service can resolve a particular host name to an environment and other things that you'll see in the UI folder. So just as an example, here's the host map for it. Now, if you're hitting UAT and your host name is neds.localhost, so you've got your local environment set up to actually point at the UAT, like the UAT config servers, and basically, or your local.env.js file has been set up just to point at UAT. It'll come in here, the config server, and it'll go, okay, well, your host name is neds.localhost, so I know that you're the UI front-end application, you're in development mode, and the brand is Neds. Then it comes back out here and goes into the UI directory. Says your UI front end, so I'm going to load up this file, which is the base front end configuration. Contains all of the base values, so things like what capture we're using, whether it's using cached, and other values up here, like there's a second capture one up somewhere. Yeah, things like whether Google Maps are enabled, or TLM, or New Relic, and all stuff. Basically a whole bunch of values. Then we traverse into the front end directory, and because we're development, it'll load the development one, and the values in here will go and then overwrite the first set of config values. And then we go into the development. Actually, it loads up Neds as well, because we're development Neds. So it'll also patch this stuff into the config as well. And then we'll go into the development directory and read the Neds file here, and finally jam that one together with the rest of them. And then after all of that, you end up with a final configuration file, which has got all of the values in it, from sort of the least specific one at the top level through to the most specific here. And then if we go to meds dot, that one. And we have a look at, because it's production, it loads the script, it loads the config directly into the HTML, and it would be like this one, no, this one, no, no, no. Somewhere.
You can search on that.
I'm usually pretty good at finding these ones. These are the not that one, the next one. So this is the config, the final config that after all of those things has been merged together. So you can see all of the stuff in here that we saw throughout the rest of the configs being set up. So once this gets executed by the JavaScript, it will store that config value into a UX store, so that you can access it at any part of the Vue application in the front end. And so when you guys are creating a new feature, there'll be something like you'll put some sort of configuration flag or something into the console key value store. That will automatically come across into your Vuex like $store.config section, and then you can get your value out and work out whether you're on or off, or what sort of parameters you're working with to do whatever you need to do. Hopefully that process sort of makes a little bit of sense to you. Maybe. And that's pretty much console. Just one thing to mention. Actually, we already covered it. We're moving away from console key value for the microservices into the config maps. So we've had, I believe it's the client service is now using config maps exclusively, so it won't be loading anything from console anymore. And I would assume over the coming, couple of weeks, progressively more and more things will start using Kubernetes rather than
Even in
console.
in the local development environments,
local, it will load. So we've got a repository for
all these companies.
all of the config maps which will go into Kubernetes, and I haven't seen the code, but I would imagine that it will, when you start up your application locally, it will know that you're not running in Kubernetes, and it will just load that file directly out of the correct $go path / whatever its path is. So we mentioned before that we've got KeyCloak. And this is our production KeyCloak UI. When you guys are doing your development, you'll have a local KeyCloak that you guys can connect to and do stuff in. Most of it will be set up automatically for you, but I'll still show you how it kind of works inside, so that you can navigate around and understand a little bit more about how roles are assigned to users in admins and things like that. In development, you'll have basically neds.localhost, betstar.localhost, bookmaker.localhost, Neds International Proprietary Limited, and Master. In production, we've got a whole heap of extra ones for the different live and UAT, and sometimes development realms, and sometimes like these crypto ones, very old websites which aren't in use anymore. Master, like the second one from the top here, is essentially that's Keycloak itself. That's this admin interface. So this realm sets who can access the admin interface and what permissions they've got for that. And if we go and have a look at the users here, you'll see like a whole bunch of users for like all of the staff in here. And, if we go and search for me, you'll see that I've got, I'll have roles. So when you're having a look for the roles in Keycloak, this little drop down here will show you all of the different roles in each of these sections, I guess, client role sections, and there'll be different things that can get assigned to you through each of these. And specifically, it's this I'm not sure where I get my admin rights from. Maybe they're just okay. Looks like I'm part of I might be part of groups which have access to certain credentials in this section. But I could, for example, go to account and give myself, well, I've already got some roles, but if I didn't have those roles, I could click them in, and that would give me direct access regardless of my LDAP permissions. So the next bit is this one here, the Neds International one. So this one determines your access levels in the Cerberus admin site. It has like a bunch of users, which again get loaded from LDAP, and it also has these clients which get created. In your local environments, you'll have these, you'll be probably familiar with these Neds admin front end users, which is the one that you have to put into your config file for front end config/local.env.js file. Has anybody here set up your front end admin? No?
No, I mean, Angeli's probably done the most. Have you been working on the system?
I am right now working in the bedsit.
Yeah, most of us have set up the dev environment once. I set up start of January, then again 3 months later, but we're not actively working on the Neds platform yet. We're working on the feed stuff. So we a lot of the stuff I'm seeing here for the first time, or maybe I skipped past it on induction.
Yeah, well, most of this gets set up automatically for you, like as part of installing your dev environment. If you do a stacks configure, it'll automatically install all these realms for you, and
Yeah,
set
so
up the
I
page.
haven't touched the dev environment since that was a thing. So so next time I do, I'll be coming up to speed.
Well, the most important part about these clients is they'll have like a token, a secret, and you need to take that secret and make sure it's the same one that's in your config file, because that's like it uses the admin passes a request to Keycloak, and it uses that token to authenticate in the back end with Keycloak and get a token that it can include in the request that it sends for the user to hit Keycloak where they log in, and it calls them back. So there's a little bit of a convoluted process there. But if these two secrets aren't the same in Keycloak and in your front end admin website, you won't be able, like your front end won't be able to authenticate with Keycloak so that it can authenticate users.
That is just for authentication, right? It's like not in terms of this service talks to this proxy and eventually talks to these services. No, that's part of the job of console. Is that correct? This is Keycloak is just only for authenticating users, client users, customers against the system.
Yeah.
Yeah. Okay.
Kind of. It also sort of jumping ahead a little bit, but it will also populate your token that it comes back with the roles that it's got in here, right? So it's not only authenticating you via a username and password or however else it's configured to authenticate you, but it's also passing back a token which is assigned like a RSA 256 encrypted signed token, and inside that token are fields that list all of the roles that you have access to as that particular person who's logged in. So it manages, in the case of front end, it manages the connection with LDAP, it manages authenticating your username and password with LDAP, and it manages sending back a signed token which contains all of those roles, so admin can verify that you are a certain person and you have permissions to do certain things. I'll jump in and I'll show you right now, actually, just to throw things in a little bit of a curveball.
What we're doing that, the token it passes back, just a regular JWT?
Yep. So this is the token here. That's not a lot of stuff. Okay, grab this one. This one looks bigger. So you can see there it's got all of my roles. That one there basically gives me all of my access. So you guys pretty much have that as well, which basically gives you carte blanche across pretty much the entire admin. Yeah, a whole bunch of stuff. So these are like AWS roles that it'll allow me to. So if I go into the admin and I click this AWS button here, it'll basically let me SAML authenticate into AWS using these roles. And then just detail about my username, my name, and everything like that.
All those roles are not attached to AD groups or anything, right? Is that correct?
Yes, so they are for admins. There's a slightly different process for end users, which we'll go through in a little bit. But so these groups here are all AD groups, and some of those groups in Keycloak have permissions to do certain things. For example, like this, where is it? This developers one here will be giving me the developers Keycloak role, which then will go on to admin and say, you've got access to basically everything. So that's that bit, and then if we go down here and pick like meds, it'll have a different client, so it's web front end. Web front end is basically, it contains the same credential, which is what you'll have in your front end configuration file to say, this is my secret we're going to use to authenticate users against Keycloak. And it's also got this user federation service here. And this is what tells it to use the V2 API, so the API gateway. That's the URL that it wants you to hit up to access things in the API gateway API endpoint thing.
Seems like how you version their APIs, your APIs. It's like if you do on version 2, you just control the feedback.
Well, this provider here is what they call in Keycloak parlance an SPI, which is a module that's been that we've written and compiled against Keycloak and installed with our implementation of Keycloak, and it determines the logic that says use the API v2 URL and put /auth/get user authentication or something like that at the end, and post this information to it with the username and the password, and then that goes and hits the API gateway, which hits the auth hits the API gateway, and then hits the Keycloak bridge service, I think. Let's just have a look here for a sec. Oh, I've got a peppercorn. Okay. Nope, localized. So it hits that API Keycloak bridge. So the URL that it'll hit that API URL /v2 /Keycloak bridge /something, and then that Keycloak bridge will then receive that API request and it'll pass it down to the auth service. So like this one here, which is then responsible for returning either 200 OK or I think it's a bad request like 403,
403 and not yes, yeah. So that setting before where you show the URL,
Mm-hmm.
that's like that's for every user, right? That's
So that's for this neds.com.au. This is basically the only SPI that we've got installed. We could easily add like a Facebook Federation plugin in here or a Google Federation plugin, and as long as we've got a mapping between their Facebook ID and our customer ID somewhere, they'll be able to log in with that third-party service. So we just instead of sending them to a page which they put instead of sending them to sending a request in the back end with the username and password that they've entered in, it would send them off to Facebook, get their OAuth from Facebook, and then come back with successfully authenticated, and then we would look up that Facebook ID to work out what the user is, and then authenticate them that way.
Yes, so this one key code you're using it for sort of managing permissions for everything, so the users of our customers, but also ask for the admin console and stuff.
Yeah.
In terms of instances and scaling, I mean, is this like a horizontally scalable thing, or is it?
Yeah. In production at the moment, I believe there's 5 of these running.
So do customers typically have different permissions, but like the moment, or like
Or you just use it as a simple federation provider, some basic credentials?
yeah, okay, so we're probably more using it for access control more for the admin side.
Yeah, generally users' access to thing is done through tags mostly.
Is the segregation here to use user data in here primarily around just not having passwords stored in the core?
No. The reason why we've put it in here is that we wanted to be able to offer both the provision of external authentication, such as Facebook or Google,
Facebook, and this is just patient 0 for it, basically.
Yeah. As well as potentially later on providing our own federated login to like third-party websites, so that they can OpenID authenticate
rather than them taking the sign up. It's like punters.com right now. I don't know if Nets is on there, but yeah, they have login forms where you enter your credentials into their site.
Yeah,
which is pretty crap.
Yeah, so we wouldn't allow them to do that. We would put it through this system, so that we would just give them a Neds log into Neds page, and then once they've done that, we'd provide the credential back to like some sort of OAuth or SAML credential back to them that they could then use to call our API on that customer's behalf with certain roles.
I saw you had a role for doors admin. For a role, a group or something. I saw it on the paper for Ned's doors admin. As long as we don't accidentally give that to a customer.
You guys know about doors, right?
Yeah. I haven't seen the app yet.
There's a few doors that are notably missing from it. I mean, I've been locked in that stairwell.
That's a separate system. Yeah.
Is that where you were at lunch?
No, I had my roast beef on the road off. So. No, I've been locked in that stairwell a few times to come back from the car, and it's the one door that doesn't work with the doors out. Yeah. And then the Wi-Fi signal itself on it sucks as well.
So if you ever have problems with like your front end UIs not being able to authenticate users or getting in authentication loops or whatever, it's generally to do with the fact that those those credential keys aren't the same in both. 99 times out of 100 will be that. If it's not, like if you log in and you have a look and they are actually the same, then the best thing to do is to tail the KeyCloak server log, and it's set to debug when it sees errors authenticating, and it'll have sections in there like, this is the exact HTTP post that I made to your X service, and this is the result I got back. So you can usually then debug and say, well, you know, the error message it got back was none available, so maybe I don't have an all service running or something. And yeah, that's basically KeyCloak. Well, I guess apart from the fact that we store, so this is neds.com. So that's my Ned's client user, not my admin user. So if we have a look here, nope, what am I looking at? That doesn't look right. Nope. Sorry, that's my corporate. That is my admin user. That's my Ned user. So this information here gets pulled back again through the KeyCloak bridge, but from the client service. It's a different endpoint, and it pulls it back from this client. So this neds.srv.client, and it will go and ask it for attributes. So once you've gone through the process where you've authenticated to the system, it will go and ask for a small amount of information to cache in KeyCloak itself, and some of these parameters are like disabled timestamp, and if that's set, then KeyCloak knows that you've put in your username and password correctly, but your account's currently disabled, so it'll send back a message to the front end saying users disabled, rather than, you know, login incorrect or whatever. Then also the client ID. So it uses the client ID so that when it provides the token to the front end, it can have the client ID embedded in there, so it knows straight away what your client ID is. Yep, and that's KeyCloak. So now I shall show you what logging into Neds looks like. So when I log in to Neds and it goes and asks for a privileged request, like product availability. So these ones, like race card and next races, they're just general requests and they don't require authentication, but this product availability one does. It'll provide an authentication token for me. And then that looks like this. So it contains all of the standard JWT GAF up the top.
So when is that token generated? Sorry, does that get generated when they log in and then like the client knows that token and sends that whatever you request or something?
So the process is that the front end has like your username and password fields which you fill in, and it generates a call through to Keycloak. Keycloak then goes back through the API gateway through the Keycloak bridge to the auth service to verify that username and password, which is then returned back to Keycloak. And if that's successful and returns 200 OK, then it will go, assuming it hasn't already done so, and have it cached, it will go back down through API gateway through the Keycloak bridge to the neds.client.service, and then grab your client details, which includes the disabled timestamp and your ID and everything, and returns that back up to Keycloak, where it will cache it and verify that you're not disabled. And if you're not disabled, then it will create a JWT token and pass that back through to the front end as the result, and then the front end will cache that token.
So that thing you sort of copy and pasted there is a JWT token.
Yep, that's a JWT token. And it contains my name, first name, last name, email address, and client ID. Now, every authenticated request that I make to the back end through API gateway or however will include the JWT token as part of the context, so the authorization token, and then every RPC call that service makes, it'll get passed along, and every call that service makes, it'll get passed along all the way down.
So at any point in that tree, a service calls you can reason about the current user, what site they came in on, and stuff like that.
Yep.
It carries brand as well, I'm guessing, in that context and pillar. So you know what?
Probably. No brand?
Yep. So if you wanted to do something different on a brand level, you'd have to explicitly pass the brand in. So
Well, it doesn't need to, because it knows what brand it is.
The service runs in a brand,
no, but
or it's not a brand service.
No, but one is when it gets, if you make a call through the core on behalf of the user, is there any situation where that would happen?
Well,
yes, and in your call through the service doing the call can inject in the brand.
Yeah, that's what I mean. So it would have to inject in a separate parameter saying I'm brand X.
If it needs to, yeah.
Yep.
There's a lot of effort put in to make it so that there's not context switching depending on the brands. It's just things exist, and if they're needed, they get done.
So generally design it so that you don't even need to reason about the brand at the core level. Try and keep that on the safe side.
Correct.
On the
Yeah.
The brand shouldn't really care. The core shouldn't really care what brand you are. If, say, you needed to do something specific for a specific brand, you'd probably implement that at the proxy level to modify the value that's coming back from the brand or from the core.
Yeah. The idea is that things in core shouldn't be going if brand equals whatever, do something, otherwise do something else.
I was thinking if, for example, that's all point forward somewhere.
Okay.
Sorry, one more time. So authentication happens once, right, with Keycloak, or is it at the end user level?
So these tokens have relatively short expiry time. So this is the expiry timestamp of that, and you need to keep on refreshing that token.
Generally get an ID token, an access token, and a refresh token. When you refresh your token every 5 minutes, or less than 5 minutes, and get a new token.
It's not that I can get hold of a token and then start making requests to all these other services.
You can for a very limited amount of time. Yeah.
I think it's 15 minutes. I think
Yeah, but the refresh is less than that.
If someone literally hacked all the service accounts and dumped out all the memory, got all the tokens and requests, within 15 minutes they couldn't use that to do any harm to us. All the tokens were recycled.
You can never revoke an access token, but you can revoke the refresh tokens. if someone gets on your refresh taken, they can get any access token. You can rotate from inside keyframe itself.
Anyway, the fact that this token is getting passed, or the authentication details are getting passed along to every service, means that a particular call, you know who's requesting you to do something. So it doesn't matter how many layers it's sort of bounced through. You've got that information. You know exactly who it is, and when I don't just log in as myself here, if I go in here and search myself, UAT is wonderful. I love it. Why is it broken all the time?
Infamous.
It's not even working. Okay.
What UAT is considered unavailable all the time.
Client ID.
Speeds up development. No UAT.
Straight
Straight
to
production.
You need the spirit of Yang.
Search client / ID.
Someone will go here, okay.
Okay. All right. Just quickly, I'll jump to production because that'll be easier than trying to work out what's going on there. Right, so if I click login as user here, just up the top there, it will open up a new session for me, and I'll be masquerading. And then if we go and have a look at network traffic, let's see if I can get the product availability or something. Spaces. New relic. Yeah, we'll reload. No, this good ones. That's a good one. So you'll see that it's got like extra bits in there that lets it know that yes, I am operating as the user Ken Allen with no dot, but I'm actually an admin. So that means that when you're down in your microservice, you can have conditional logic based upon not only just who the user is, but also who the admin is, and also what roles and permissions.
So when logging a transaction up there, you can say that, like for example, this bet was placed for Ken Allen masquerading like player.
Yep. And you can also have different logic for an admin user than you would for a normal user. You can say, well,
we can bypass the light betting into locks and stuff like that.
Yeah. Okay, so that's key cloak authentication section done. I've got a section here to cover microservices, but we've actually done a fair bit of this as part of the other stuff. So essentially, kind of covered this a little bit, but as far as microservices are concerned, the database is merely a storage layer. when it comes to the single source of truth for a microservice, it is it. So when it loads information from the database and it performs an operation on it, it considers the fact that it's authorized that to happen as fact. And if something else in the meantime has come along and modified the database to say something else and hasn't published information to say that it's updated that object on the bus, then the service essentially, what's in its memory is correct, not what's in the database. So it will overwrite what's in the database with what it's doing at the moment.
How do you control that, or
We don't.
call it that? Oh,
People don't write directly to the database. You have to go through the service. Like any updates and modifications that you want to make to the database must go through the microservice. If you're directly updating the database without knowing what you're doing, your changes are likely to get overwritten. So
two services cannot create that scenario. Like, for example, one updates transactions table, and then immediately the other service because the manager requested a cancellation of event, kind of like gets into that deadlock or whatever the thing is.
No, it's all transactional, and
so the client service wouldn't say, "I got $64 in my balance. I'm gonna place a bet." Since the request, well, that request happens. Someone canceled that bet, or I don't know, can remove the client balance, and then it's like, "Oh, you got $0, but the request was made."
Mm-hmm.
So I shouldn't be worried, I guess.
Yeah. So
if that happens, it will happen.
it shouldn't happen. And the reason why is that the client service will never write directly to the transactions database.
Mm-hmm.
Transactions is the domain of the transactions microservice.
Mm-hmm.
So it has complete control over that.
Oh, yeah.
And if client, for whatever reason, wants to update a client's balance or place a transaction in the client's transactions table, it has to make a call to a transaction service to do that. It will never do that directly.
It doesn't have the permission to anyway. Even if you wrote the queries, they would fail.
And the other thing is that even though we're running multiple transactions services, they will coordinate things with each other to make sure that they're not, overriding each other.
Yeah. How do they do that? I can ask a question in a different way. So we do the feed processing that we do. We avoid deadlock by making sure that messages belonging to the same event go to the same instance. So even if I have 7 bookmaking import services, we know via our message grouping strategy that everything belonging to the same event is going to that one instance, so that deadlocking can't happen. So how do you guys manage that sort of scenario?
Similarly,
Yeah. Really the only place that we currently see deadlocks at all occurring are requests coming from resulting due to how parallelized it is, and we're fine with them failing because then they get picked up when it goes and retries anyway. So it means that person doesn't get that bet finished being resulted in, or whatever part of that gets deadlocked. The query fails, but it's not a, oh no, this is a really bad thing. It's just the person didn't get their payment until 2 minutes later.
and then other services where it does actually need to be, separated out like that. That we implement like a sharding selector for our RPC calls, which essentially takes whatever parameter we're sharding on, for example, the client ID, and then it runs it through a little algorithm, which means that it always goes to the same server for as long as that server is running. if you start up a new server, then that new server will get a certain percentage of all of the traffic from the other servers redistributed to it. So that any new calls that are coming through for a particular client ID that used to be on that server will now go to that server.
So similar.
Yeah.
And the same thing with shutting down. Like if you shut down that server, then all of its traffic will be equally redistributed across the remaining ones.
Is that your dev environment?
Yes. Yeah, we've covered everything else I wanted to talk about now. No task manager, self-caching, and update publication. So we've already done all that.
Auditing, the audits, like I know that bookies and even via you guys that rely a lot of auditing and logging. You know what this user did at what point or what happened. I guess is managed at each server level, right? Is that correct, or is there a middleware layer that grabs all the requests, dumps it into Sumology, and then I don't know, like.
So there's drivers in Kubernetes Docker instances which cause the output to be logged. I think this is still how it works. It causes it to be logged to AWS CloudWatch, which then passes it along to Synologic
Yeah, maybe
via an ingestion feeder or something.
maybe it goes directly now or something. That's what I'm doing. So the RPC calls themselves have a middleware that adds like Prometheus metrics tracking, and in some cases there are audit ones as well. Some services themselves individually call audit on certain things. From a front-end perspective of what people are doing, we push events to New Relic and use it as our
TLM? Well, not really anymore.
So anything that goes through the admin router stuff has audit logging as part of the middleware for it. But there are certain services that have additional. I actually am calling the audit log.
Okay. I shall take you through GitLab.
Not that one.
No, not that one. Why do I keep on typing that one? I don't know.
I think it's because right beforehand you say GitLab.
Yeah,
So
it is.
GitLab.
Okay. So essentially, we've got for our older services and things, we've got everything in the root directory. So basically, uservice, golib, and UI and feed processing. They all contain older versions of our services that existed before we started moving to this new structure. And I think a few of them have been moved out since, but generally it's a bit of a hassle to move them, so it's a pretty slow process. Essentially, if you want to move it, you've got to update it and then update all the projects that reference it, and then rebuild them all and restart them all. And nobody wants to do that, so so yeah, in here, like all of these projects, 5 pages worth of them. They're sort of all of our original microservices. And then in UI is empty. Not empty?
Yeah, because it got moved.
Okay.
Technology code UI. No. Okay. Have I been grayed out?
It might have been.
Yeah.
I couldn't access admin before. I couldn't do a search for user. They're supposed to wait until I finish this on Friday.
There's a whole lot of them there.
Okay.
Sorry, Ken.
It's been nice seeing you guys.
Because the old UI folder should redirect to the code UI folder.
Oh, okay. Yeah, so there's admin and front end. They're the two big ones, and a whole bunch of smaller ones. So generally, when you guys are producing new microservices, so most of the stuff that we'll be adding will be implemented as new microservices rather than tacked onto old ones, just because it's it's a lot easier to get approval and release on a new microservice rather than modifying the behavior of an existing service, which involves all that regression and testing and stuff. So most of the stuff that you will be creating will go into this technology group now. And the reason why we've put everything under this technology header is just so that it's a little bit more structured, and we can have what do they call those things on the side? The tags, the issue tags.
The labels.
Labels, that's the one. We can have like a common set of labels under the technology tree. We can create like issues which go across the whole group rather than just being restricted to microservices or feed processes or user interface or anything like that.
Boards and
Yeah.
issue boards.
And all of the code, all of the new code goes into the technology code folder, and you'll see that there's group directories for proxies, tools, libs, webs, the UI stuff which we were in just before. I talked about scheduled jobs before. These are the few scheduled jobs that we've got. The blue shift ones to expire codes and refresh locations, as well as the my affiliate stuff, just to perform syncs of our affiliate information. And the services and the APIs. Right, and then there's the issues that we have there to group all the issues under the code directory. So that means we can create an issue there and reference it in like any of our new microservices. And then just in here, we've got the fully correct named service name for all of these things. Inside tool, you'll see we've got stacks and Neterator, which I'll be introducing to in a bit. This kitlib is it's the main way that we start up a microservice. So it's just a whole heap of common code that we've written together to produce a service with certain methods on it to be able to build bridges and get clients and get a broker for the pub sub stuff.
get login adapters and all sorts of stuff. So essentially you make one call to this kit.newService, give it your service name, it returns an object which then has all of these things on it, just to make it easy for you to get the various bits and pieces that you'll need to write your service. And then we did UI. Yeah, in services we've got one of these new services. So that's
Are those core services? Oh yeah, they are core services.
oh, they're all sorts. So some core, some not core.
Core and core in there.
And core services are kind of brand agnostic, correct? Yeah.
So there's two different types of core services. There's a service which runs in core, and then there's those srv.core something or others, which are the aggregator ones, which aren't like a core service, but they talk to brand services for core. If that makes sense.
It's like the proxy one.
Yeah. So they'll talk across the bridge to the individual brands to get the information, so that core has that. So they're differentiated by having that srv.core in them. Yeah, that's basically that's where you put all of your stuff when you're creating new services. Okay, so got about 45 minutes left. That should be long enough, I think. Well, first of all, any outstanding questions or anything you didn't understand up to this point?
Or even average questions.
Or average questions even. Yeah, all good?
If it was possible to do it like this before, why Bookmaker, guys? That PHP monster.
A lot of it was around the database that already existed.
Yeah, generally.
And the requirement that we use PHP. That was a fixed requirement that was argued against at length. But
Was it Gary's idea? You can say it's a safe space.
it was Dean. Yeah.
Really?
Yep. We tried really, really hard, but yep, you can see me good. So in the technology code directory, as you saw, we've got these things. So for example, if I go into the SRV directory and I want to create a new service, so these are the ones I've got checked out at the moment, I can simply create a new service by iterating neds.srv.test.
Is that the template that I think Corey was showcasing like a few months ago?
Maybe.
Yeah, it's only just for the last couple of months and it's actively worked on.
Prior to this, it was, I'm not sure what's going on here, but prior to this, you basically just copy and paste an existing directory and make changes to it.
Pick something that was similar and go from there. Start with an empty directory.
We do similar, but Steve Reardon created a similar tool for us.
We use something called cookie cutter, so if we need to bang out a service, we just use cookie cutter, it constantly posts the substitution, then pushes it in, so within 2 minutes you've got it deployed out to all the environments with like production staging. It's just that it's just a hello world service that you just iterate from
Same
there.
sort of thing.
Yep. So that's created this. it's generated all of the files that I need for the service, and if I go into the directory, you see I've got a whole bunch of files there, and if I set up my environment, I can go run dash tags.
So what that about when user eval?
What?
What that prior command eval LKA?
Oh, that just sets up the environment variables I need to connect to console and everything. It literally does.
So if you did aim for now, there'd be a whole bunch of crap there.
Hey?
If you just ran aim for now, there'd be a whole bunch of stuff there.
Yeah, so yeah, basically just does that. Right, and because I eval it, it puts it into my current shell's environment.
So, so then you start off with the service and it's just composer
Mm-hmm.
HTTP, so or with health endpoint or something.
Yeah, so it starts up an RPC endpoint. So then if I go to my local console, see for my NEDS environment, I've got a service. Scroll down here, and you can see my new service, which has registered itself. It says that it's loaded up on my IP address on port 55113. And you go in here and have a look, and it's 55113 is what it's listening on. So that's me that's registered there now. So if there's any service out there that's looking to connect to a neds.server.test to send it an RPC call, it would now be able to find me.
So what you just created was a core service, correct?
No, I just created a service.
Any service.
Any service. Can run in core, can run in brand, can run in core and brand.
And obviously, I remember after that we need to create like a proxy and the other one, right? Is that correct?
Yeah, depending on what it needs to do. It might be a brand service which only needs to talk to brand, in which case, if that's the case, then you'd create a service, and then if you don't need to access it from front end, you wouldn't even bother creating an API. If it's just a service to sit there and run there and provide information to another service somewhere else, you just create a service, you'd run it, and then any other service in there can talk to it. If it's a service which sort of fits within the sort of same topic as an existing API, you just add your call to that API, update it so that it knows to send a certain request to your service, and then merge your code in and get it redeployed. And yeah, if it's completely separate out of everything, then you create your service, you create an API for it. And then if it was a core service and you needed to talk to it from brand, you'd have to create the brand stuff. If it was a brand service and you needed to talk to it from core, you'd need to create those core services. So there's this command called micro, which is just a CLI RPC client, and you can get it to send requests.
Is it based on a gRPC code?
Yeah.
Yep, exactly like that. You can see I've done this a bit before.
How many sessions of this now?
This is the fourth one. So that's all of the template code, basically doing a hello world type RPC. Not even in SRD. Technology code. Yeah, okay. Must just need to refresh. There we go. So, out of all of this code that's been generated, there's really only 3 files that you need to worry about. The first one is the proto file, which looks like that. Get rid of that. And essentially, this one defines what your RPC service is going to look like. In this case, it's saying that we're creating a service called test. So if you recall over here, I sent it to test.hello. So that's where that test bit comes from. And hello, that's where the hello bit comes from. And it says that my test.hello is going to take a hello request, which is this message down here. Closed it. So it's that message there. And it's going to return a hello response, which basically contains the greeting that we receive back. When this code is executed, when this code was built, it created these 2 files here, test.pb.go and test.micro.go. This one defines all of the messages that are part of my RPC call, and this one defines the methods that the RPC call will use.
So,
No, I'm just going to ask to repeat that one for sorry, the 2 files again, sorry. Usually ours are converted into 1 file, so I didn't catch what was.
Yeah.
One is in the model and one is in the methods.
Yeah. So this one is the proto buff, which contains the generated GoGo protobuf code. Right, and it basically contains just the messages and how they're going to be interpreted, and the methods which exist on those receivers, and it registers the types with the proto and everything like that.
We use ducks and blood interfaces. This one.
So the interface
it's the
is
same code gel we use.
Yeah, but I was going to.
But they've got a file that they use with a name that's a follow convention, and they put extra stuff in, but that's on micro file.
I really don't want to digest too much, but GoGo Pro, I saw you use that recently. What's the different one up with Google?
So basically, I'm guessing Ned's probably using the same thing just because it does its reflection for the marshalling. Is that the principal reason?
yeah. So this one directly
It just
assembles.
Yeah. So rather than the default Google one uses reflection, and it's it's looking at the. So when we were pumping up 1 million messages a second, so it was showing itself. So that's how I mentioned that CPU there for template.
Yeah, so it uses these functions in here, not those ones. Yeah, like these ones, encode variant. No, not even that one. I think it's probably because we don't actually have any non-stringy things in there.
But yeah, it's the encoding and decoding performance change.
Basically makes it faster. Yeah, but I mean, you won't really ever have to go in and have a look at these files even. Once they're generated, that's it. So if I want to make a change to this code, for example, and add an int64 field to it, I save this proto file and I come back to my code. What's that?
Oh, it's just referencing an earlier comment of formatting.
Julian license equals alignment.
Just run make generate in the main folder, and it will go and recompile those things for you. And then if we have a look in here, we can see that this has now been updated, so it's got a second field in there.
Is it possible to compile just one file?
Compile just one file?
Yeah. I'm just asking. It has to compile everything in it.
Yeah, you could.
You could.
You could. As you can see here, we've specified our proto-c command to run both the go module and the micro module. You could just run that same command, but just with the go or just with the micro, and it would generate one or the other. So I'll just quickly take you to the main.go, and again, you really shouldn't have to modify anything in this file, but just to show you what it's doing. So I mentioned before this kit library, where you call new service, and it returns this object, and this object's got methods on it to create like a server, to create a handler, to create a logger. Actually, that's not creating a handler. So these things here, like service.server, service.logger, that's all calling methods on this thing to get a new server and a new logger, which I can then pass the logger to my handler, along with this greeter object which I've created up here, and then register my new handler against the server that I've got there. And then finally I run my service down here at the bottom, which then goes and starts the whole process of registering in console and maintaining a timer where we re-register with console so we don't disappear or stale and all that sort of stuff, as well as handling any RPC requests which come in and going away and processing them against this handler. And then this handler is one of the pieces of, it's sort of like the second thing that you'll modify when you're creating a new service, and it basically determines what happens with your methods.
So does it serve a HTTP server and a gRPC server and direct both of those endpoints through to the service?
No, it's only RPC.
Okay.
No.
Does it do any health endpoints?
The health is the fact that it's continually registering itself with console.
Okay, so you have like readiness endpoints, so like to say
No,
well, your
it's
dependencies.
not a full gRPC service.
Yeah. So the readiness checks that we've got in Kubernetes are just to check that it's currently registered in console. So it does a check against the console API to say, is the service registered? If it is, then we're ready.
And that the ports respond.
And that And that happens when you set kit.news, when you use that kit module, right? Is that correct? Because I don't see code
So
registering
run.
against console. Yeah.
Yeah, so it's this
Inside
bit
the
here.
run.
So, I mean, if you're interested in how it all works, delving into that kit package will show you like all of the guts of what it's doing inside there. The important thing to understand is that it's not a gRPC service. It's a Go micro service, which is almost, but not quite the same thing.
Similar.
Oh, so when you said RPC before, I was assuming the RPC. But
Yeah.
okay,
RPC.
I probably don't need to know the difference. But anyway, you sound like seems like you've abstracted a lot of the boilerplate codes. You can just get in and write your logic.
Yep. This SVC, I believe, can start up a gRPC server.
No.
Is there something else in Kit that does that? Is there?
No, so the split between the service and the handler is so that at some point we can actually start serving the gRPC endpoints with the service being consistent between whether it's gRPC or micro or HTTP or anything else.
I'm sure in here I had it running dual gRPC / micro or somewhere. I don't know, maybe I was dreaming it.
Shouldn't be unless you're generating more proto stuff.
I don't know. It was ages ago. Seems like ages ago. It wasn't probably that long ago.
It's probably Wednesday.
Yep. So getting back to the topic, the aim of this handler function is to keep the code that goes into there as minimal as possible. Back in the early days, and if you have a look at any of the old services that we got written, we just jam everything into this handler. We ended up with like 100 files in here and services all across the spectrum, and files were like a billion lines long, and it was messy. You go and you try and find anything in there, it'd be like scrolling through like 10 pages of text to try and find where everything's going. So the new pattern is to, when you create the new handler, you pass it basically handlers, which will go and do certain things for you. And in this case, the handler that we've created is this new greeter service, and that gets passed in the handler.new, and that exists down here. So greeter is an interface. Do I need to cover what interfaces are?
No.
It's no? 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 All no's? Good? Okay. Yep, so new greeter just creates a new greeter service, which is that struct there, empty struct, and then defines on that greeter service handler a greet method which takes a name and returns a string and an error. If the lowercase of the name is nobody, returns an error with an empty greeting, and if the name is empty, then it returns, it uses world as the name, right? And then it returns hello, comma, space, name, exclamation mark, with no error. So just to show you that working, if I give it no name, returns world. If I say that I am nobody, returns an error. So that's it, handling that error up there. Unable to greet nobody, returns an error from neds.serve.test with 400 code, unable to greet nobody, status bad request. So any service which is calling us, when it returns, it will return the return proto as well as an error. And if this service returns an error, then it will get the error. So if I want to modify this and pass through the requested number, I need to go and modify the interface, so it now takes a number Jeanette64 and modify this method so that it returns it takes also a number Jeanette64 and does something useful with that number. That should be it. So I can restart application. So I ran that before it managed to register itself as console for the first time, so I couldn't find it. So that's what you see if it can't find the thing that it's looking for in console. So yeah, now I can just give it a number. Yeah. So yeah, that's a service, right? And typically you would go through and strip out all of that hello world guff and put in your own RPC methods and message types and everything for whatever you want it to do. And then, yeah, rewrite your handler. Probably gut this greeter out of here and create your own service object. Any questions? All pretty straightforward so far?
For the various forms of services, so the properties and so on, is there a generic boilerplate reference code, or is it generally whatever people?
Yep. So as long as you type in the right name for that netarate function, it'll go and create the required type. And as a matter of fact, I'm about to do an API.
So one of these Apple presentations and one more thing.
So yeah, it's generated that, and I can again come in here and because I didn't eval my environment, I just echoed it out. What am I doing? Micro. So I was going to do basically the same request, but with an API here. Uh-oh.
You goofed it, Ken. You goofed it.
I done goofed it.
Done goofed it.
So what was this? It was an error that said, panic recovered, implement me. And that's because of that. Because it's a API, it's not technically allowed to do anything like generate greetings or anything. It has to pass this request on to something, and at this point we don't know what that something is. We can't generate that in template code. So if we go in here and have a look at this test.proto, we'll see that we've got a similar type of structure, but these are empty. They don't contain our name or number or any greeting text in response. And the reason why they don't contain any of that code is that we're not actually supposed to use these these messages in here. Because these would be neds.api.test.hello requests and not neds.serve.test.hello requests. And if we want to be able to take the message and pass it down to our service, it needs to be either of the right type, or we need to create an equivalent type in here, and then before we pass it down we need to create a copy of the correct type and then copy all the fields across from the old type to the new type so we can pass the new type down. So generally what you'll do in your proto file as the first step is you'll delete those types and you'll go and import the proto that contains the types that you want. In this case it's a git.neds.sh/code/srv.test/proto. And then you see the package name up here. In our serve, it's called neds.serve.test. So our type in the proto file will be the package name from the other thing that we've just imported. So that's a neds.serve.test.hello request, and it returns neds.serve.test.hello response. And then we can go and make generate on that. So now over in our handler, it'll say, that we've got the wrong type there. So what we want to do is we want to import the SRV versions here. And these are both going to be called test. So if we have a look at the proto buff here, you'll see the package name is test. And it'll be test for both of those. So we need to alias one of these to something else. And then we can use that down here as a serve test.hello request and a serve test.hello response. So that's basically modified now, so that our hello API RPC call is taking the correct hello request for us to pass down to our service, and it's returning the correct hello response that our service will return. So all we're left to do is now create a client, a service client for us to talk to our service, and that's easily done by calling srv test.newTestService. We give it our qualified name, so that's always in servTest.qualified name, and that equals see the resolved value is neds.srv.test, and we need to give it a client. So you'll remember I mentioned before that this service thing will give us lots of different things. And one of the useful things that it will give us is a client. Once we've got that client, we need to pass it into our handler, and then in our handler we need to modify a definition so that it can take a kit.client, and in our test handler definition we need to add that field so that we can store kit.client, add the kit.client to add the kit.client to that, and I like to add the keys just so it looks nice and neat. And yeah, so now we're returning a new test handler which has the client in it. We can accept that as a receiver there with the context, which we call CTX, because we always call CTXs, context as CTXs. We'll call that request REQ because we always call our requests REQ and RES for the same reason. And we can now pass that a client from our receiver, and that will return our service. That service client has our hello function on it from our server, and it takes a context and a request and returns a response, which we call RET because we've already got RES, an error, and if the error is not nil, we'll return that error back up to our caller. Else we'll set our responses greeting to the returned greeting. With these RPCs as well, there's a nil safe get greeting on them, and if you do that, then if the return object is nil, it will still return empty string. So it's basically a nil safe. It's got this condition up the top of it which says if my receiver is nil, then if my receiver is not nil, return the greeting, else return empty string. So it just means that we don't have to check return is not nil before calling that. And then why can't I not spell? Then we return nil because we don't have an error. So that's essentially that bit, and we've now got a API service, which when we restart it, we can send it this request again, and it will return exactly the same as the other one. Ooh. So those calls are going from our micro RPC command line client, hitting up console, getting an address for Ned's API test, connecting to the RPC endpoint, calling test.hello with the payload, which is converted by the client into the protobuf. That's calling our client, which is running there. It's using its client connection to the neds.srv test to forward the protobuf message down to neds.srv.test. It's using its service.greeter to generate a greeting for that and passing it back up to the API, which is then passing it back up to the CLI and then outputting that. So that's all well and good, but that's not really the point of an API service to call it via RPC. The point is that we can call it via our API gateway. So if I add a request here that posts to my API gateway, which is there, and I post through a JSON body with a name, Ken, and number,
How does it know hello on test?
so that's how it knows it's a test, and that's how it knows what method to call. So the method, like, it's all case insensitive up here. Do you like that?
Yeah, so you like API gateway, yeah, converting it into an RPC call.
Yep. So API gateway is taking the first part of that URL, which is the test, and it's saying, okay, so I need neds.srv.test. It goes and looks up the neds.srv.test, and I don't know if you recall, but when we had a look at
Does that mean that those new services are exposed by default, like to the public? Because you didn't go into anywhere to configure that's a publicly available URL, right?
Sorry about that, I didn't hear much of that.
Yeah, sorry,
I thought that's your phone and you're not answering it.
so you made a service, then you were able to access those services via a URL. in production, would you be able to do that without configuring that URL is publicly available?
Mm-hmm. As long as the API service is running in the environment that the API gateway is running in, it will be able to find it and send requests to it.
Oh, okay. So the presence of the service in that API gateway space means it's publicly available. Yes, got it.
And the way that it works out what the methods and everything are, if you have a look at this, so we'll go back out and have a look at the neds.api.test definition, you'll see that we've got these things here that look like that. So if we go and visit that, it will return basically a big bunch of JSON, which defines the names of our methods, what types it takes. So it says it takes a hello request, and a hello request contains a name, which is a string, and a number, which is net64. A lot of that stuff was just ignored because it's all name hyphen, which basically means ignore me. So they're all internal go types. They're the XXX underscore whatever things that you saw in there. And the hello response is basically returns a greeting. So that's how it knows the types that it needs to create and how to encode all of that sort of stuff. So it'll take your JSON, it'll use this information to convert that into a proto message, which it then passes along to the API service. The API service then forwards that along to the SRV service, which then processes it and returns everything back up.
In terms of just thinking in terms of, say you got a common structure which doesn't really change across the different layers. Example is like the fractional pricing, for example, and you get a new rate denominator. Would you create an external repo that houses that gRPC proto and then share that across the two to have the shared contract, or do you just double up and do manual mapping?
Generally, we share the protos as much as possible.
So, do you create a third repo for that to serve that need, or do you just cross-reference it using GoGet?
Probably should for most things. We haven't been doing that for a lot of things. Some things we have.
So sometimes you deep link into the proto from other projects.
Yeah. The only reason not to deep link is that you end up with these convoluted dependency, and if you end up with a cyclic dependency and go, it's like that's it, end game.
Yeah, certainly for the feed services, we tend to have generally, if it's straightforward, if there's anything shared, we try and externalize that contract and then have that.
Yeah.
But yeah, that you end up with a lot more Git repos just to share a few bits and pieces.
Yeah, I mean, even if you, what we've typically done is we just create a new directory in that proto folder for the type, like for the separated type, and that way you don't have another repo for it, but it's
segregated from the main the RPC definitions.
Yeah. So a good example of that is we're going to have a look at. Not that one. Bonus. Why have bonus? Oh, because it's not API. Never mind.
It's all good. I'll take your word for it.
Yeah. It's basically two in there. One's the main proto for that thing, and the other one just contains the types.
Sweet.
No. Okay, I don't know what I'm talking about.
I'm sure we'll come across it.
Yeah. Anyway, that's it.
Yeah,
Thank you very much on time.
That's great, thanks.
Thank you. Thank you.
I think it's the first time I've seen some of this stuff since the due diligence process.